In this video, you will see how to create a parametric dam within the 3D Experience platform using the civil engineer role with the Civil Engineering 3D Design app and Terrain Preparation app, and also the polyhedral modeler. We will do a really simple example to show the benefits of parametric design and design in context. I start the tutorial with only a geolocated terrain for my project. First, we will create two parameters. A real that will define, using a ratio, the position of the dam along a curve. We can set the range of the authorized values from 0 to 1. And I create also a length parameter to define the height of the dam. Then we create the plane that will be on top of the dam and we link it to the parameter dam height we just created. I activate the colorize by height map to better visualize the elevation of my terrain. On the top of dam plane, we define in a sketch the flow axis. Here a line, but it could also be a curve, defining all the different positions allowed for the dam. On this line, I define the anchor point for the dam and link its position to the dam position parameter. This way, I can now move the point with the parameters, either along the curve, either change its elevation. Now, I create a plane that will host a cross-section of my dam by rotating the top of dam plane around the flow axis. On this plane, I create the cross-section of the dam, here a simple shape. I constrain the top of the sketch with the top of dam plane so that it will follow the changes induced by the dam height parameter. I then project the point on curve created before in my sketch and create an equidistant constraint with both extremities of the top of the dam. This way, the dam position will also be driven by the point. The width of the dam is set to 10 meters. It could also be driven by a parameter through a formula. I define the slopes of the dam. Slope downstream is linked to the slope upstream through a formula. I can also change the units to slope units. Don't forget to switch the projected point to construction element. This can be done in the sketch analysis tool. Now I create a solid from the sketch and I want to split this solid by the terrain. To do this, I need to turn on the polyhedral modeler by right-clicking on the terrain and use the command Enable for Engineering 3D Design. Now I can split the solid dam by the terrain. This is a design in context, meaning that if I move the dam along the line, the solid dam will be automatically recomputed using the terrain as context. I measure the dam and display only the volume. This can be set in the Customize tab of the Measure in Part command. Now I create a second solid body that I will use to define the volume of water behind the dam. I create a reference plane for the top of the water, 2 meters below the top of the dam. Water could be anywhere on my terrain, so I define the maximum envelope for the water and I create a solid from the sketch using a pad. In my dam cross-section sketch, I create a line which is constrained with the upstream slope of the dam that I will use to split the water solid. This line is set as an output feature so that it can be accessed independently of the sketch as a single feature. I use this output feature to create the split surface and use it to split the water solid. I can measure the volume of water. I now split the water with the terrain. Notice that the volume is automatically updated. Finally, I can play with the different parameters to change the height of the dam or its position. With just an update, I can get the new quantities and the new 3D representation of my project. This is really useful in a preliminary phase when I want to perform quick iterations and see the impact on my quantities. Of course, I can add more parameters and more context to my design to define something more realistic. Not only we can drive the geometry and perform quick iterations, but we can now use the parameters to optimize automatically the dam position and height using a target value. This is what we can do using KPO, the Product Optimization Designer role, and the Design Optimization app. To do this, I will create a new parameter which will be the volume of the water behind the dam. This is the value we want to optimize. Then I go to the Design Optimization app and create an optimization. There are different ways of optimizing, such as minimizing or maximizing a value, but here I will pick a target value. The parameter to optimize is the volume of water, and I want to set its target value to 40,000 cubic meters. Then I set the degrees of freedom and define the dam position and dam height parameters as three parameters that can be adjusted to achieve my target. I can define a range of values if necessary. I choose the algorithm type I want to use, the convergence speed, and a maximum number of updates. I want to visualize in 3D the updates while my optimization is running. Now, I run my optimization and Katia is automatically adjusting the three parameters to reach the target value. Now, I have reached my target and I know what should be the position of my dam and the height to achieve my requirement.